Okay, question 15, part A. We're asked to complete the table of values for y equals x squared minus 2x minus 1. So we're going to have to substitute the different x values into the function to get the corresponding y value. Now, I'm going to start with the positive values of x because they're a little bit easier to work with. I'm going to start by substituting 3 in for the x. So that gives us 3 squared minus 2 lots of 3 minus 1. Tidying that up, we're going to get 9 minus 6 minus 1. 9 minus 6 is 3. 3 take away 1 is 2. We're going to do the same for the 4 here. So we're going to do 4 squared minus 2 lots of 4 minus 1, which is going to be 16 minus 8 minus 1. 16 take away 8 is 8. 8 take away 1 is 7. Okay, we're going to substitute in 0 now. I should have actually started with this because this is probably the easiest of the lot. 0 squared minus 2 lots of 0 minus 1. Hopefully you know straight away. It's going to be negative 1. And then lastly we've got to substitute in negative 1. So we're going to do negative 1 squared minus 2 lots of negative 1. And then we've got to take 1 away from that. Negative 1 squared, be careful, I should have some brackets around that. Negative 1 times negative 1 is positive 1. Negative 2 times negative 1 is positive 2. And then we've got to take that 1 away. So 1 plus 2 is 3. 3 take away 1 is 2. So that's the first part of that question sorted. Part B, we're asked on the coordinate grid to draw the graph of y equals x squared minus 2x minus 1 for the values between negative 2 and 4. Essentially, take these coordinates, which you've actually just worked out, and plot them on the graph, and then draw the graph. So, negative 2 and 7, negative 2 and 7 is here. Negative 1 and 2 is here. 0 and negative 1. 0 and negative 1 is here. Just scroll back up a wee bit. 1 and negative 2 here. 2 and negative 1. 2 and negative 1 is here. 3 and 2. 3 and 2 is here. And then finally 4 and 7 is over here. So don't forget, after you got all your points plotted, you need to draw a smooth curve. I'll do my very best here. It may not be smooth, but do not use a ruler. This is a quadratic graph. It should be a smooth curve. This is not too bad. That goes through all the points that we plotted. And right up there. Okay, that's not dreadful, but hopefully you can do a better job on that. That will get us 2 marks. Just bear in mind as well, folks, if you made a mess of your table and you weren't too sure about it, I would always suggest make sure you plot your points and draw some sort of graph, because you might be able to nick a mark, even if it's not right. Okay, part C, we're asked to solve x squared minus 2x minus 1 equals x plus 3. Notice, x squared minus 2x minus 1 is what we've just drawn the graph of. So I actually have the graph of that, and I want to know where is it equal to x plus 3. Well, why don't we just draw the line x plus 3? So if you know how to draw that line x plus 3, let's get it on the graph and then see where the two functions are equal to each other. Where do they cross? So I'm going to mark, I know where x plus 3 is going to be. It's going to pass through the line, or pass through the y-axis when y is 3, and it's got a gradient of 1. There's actually a 1 in front of that x, so that means the gradient is 1. So for every 1 across I go 1 up, so it's going to go through there. For every 1 across I go 1 up, and so on. And then now I should be able to draw that line in. This time I'm going to use a ruler. So we go in that direction, and likewise we go in this direction. So where are the two graphs equal to each other? When I make it when x is equal to 1 and where x is equal to 4. So where x is equal to 1 and when x is equal to 4, the two graphs are equal to each other. You can see from here. I just want to absolutely make sure that this is the point that I'm thinking of. Yeah, it's definitely there, and it is indeed definitely there. So we just read it off from the graph. When x is 1 and x is 4, I was a wee bit unsure because my graph is a wee bit wobbly, but x equal to 1 and x equal to 4 will get you full marks. So we got 6 marks for that question in total.